Welcome to the DIY Honda Garage channel. The DTC P24B9 indicates a problem with the Evaporative Emission EVAP leak check module pressure sensor's range or performance. This specific diagnostic trouble code is triggered when the Engine Control Module, PCM, detects a significant discrepancy between the measured pressure sensor value of the Evaporative Leak Check Module, ELCM, and the barometric barosensor value. Located in the EVAP system, the ELCM plays an important role in assessing the system's integrity by monitoring pressure changes. A faulty ELCM sensor can disrupt the vehicle's emissions control strategy, potentially leading to increased pollutant emissions. Understanding and addressing DTC P24B9 is essential for maintaining compliance with environmental regulations and ensuring optimal vehicle performance. The DTC P24B9 primarily affects the Evaporative Leak Check Module, ELCM, pressure sensor, a critical component responsible for monitoring the pressure within the EVAP system. Its role is to ensure that the pressure level remains within a specified range, which is essential for effective emissions control. Located within the broader EVAP system, the ELCM sensor is strategically positioned to assess any leaks or abnormalities in pressure that might indicate a leak in the fuel system. When the ELCM pressure sensor's readings deviate significantly from the standard expected values indicated by the barometric barosensor, the PCM triggers DTC P24B9 to alert the driver and technician about the potential malfunction. Hence, addressing DTC P24B9 is crucial to maintaining the integrity of the EVAP system. The potential causes for DTC P24B9 include a faulty ELCM pressure sensor, a blocked drain tube, or a malfunctioning canister one-way valve. A faulty ELCM pressure sensor might provide inaccurate readings, leading the PCM to perceive a discrepancy with the barosensor. Additionally, a blocked drain tube could prevent proper airflow or pressure balance in the EVAP system, triggering the DTC due to abnormal pressure levels. Furthermore, if the canister one-way valve is not functioning correctly, it may fail to allow the release of gas vapors, causing pressure imbalances. Each of these factors can contribute to the overall performance issue of the EVAP system, necessitating thorough inspections and diagnostics to pinpoint the specific cause of the DTC. Common symptoms associated with DTC P24B9 include the illumination of the check engine light, CEL, reduced fuel efficiency, and potential failure during emissions testing. The CEL warns drivers of underlying issues within the vehicle's emission control system, prompting immediate attention to the issue. Poor fuel efficiency can result from an improperly functioning EVAP system that allows gasoline vapors to escape, leading to incorrect engine management by the PCM. Moreover, an abnormal pressure condition indicated by this DTC can contribute to higher emissions, increasing the risk of failing an emissions test. Identifying and resolving the underlying cause of DTC P24B9 is essential to restoring vehicle performance and compliance with environmental regulations. The first troubleshooting step for addressing DTC P24B9 involves turning the vehicle to the on mode. This action supplies power to the vehicle's electrical system and allows the PCM to perform self-diagnostic checks of the EVAP system, while also facilitating the monitoring of various sensors. It is crucial that all systems are active in this phase, as it allows the technician to capture the necessary data required to assess the condition of the ELCM pressure sensor and its functionality. While the vehicle is in the on position, the technician can review the current pressure values from both the ELCM and the barosensors to identify any discrepancies that led to the DTC activation. This step sets the foundation for further diagnostics and thorough inspections of the EVAP system. In this step, the technician disconnects the drain tube from the Evaporative Leak Check Module, ELCM, to facilitate further diagnostics. This step is vital as it allows access to the ELCM and enables a pressure test to determine the integrity of the system. By disconnecting the drain tube, the technician can ensure that any blockage or malfunction in this component is isolated, thereby narrowing down potential causes for the DTC. It is essential to handle this component carefully to avoid any subsequent damage. After the drain tube is disconnected, the next phase includes connecting a vacuum pump and gauge to assess the pressure levels within the ELCM system accurately. For this step, the technician connects the vacuum pump to the hose that has been attached to the drain tube of the ELCM. This procedure enables pressure to be applied to the EVAP system, which is crucial for evaluating its performance. A vacuum pump is specifically used to generate a negative pressure. The gauge allows for an accurate measurement of the vacuum pressure created. During this test, it is imperative to observe the gauge reading closely to ensure that the pressure stabilizes at the anticipated level. Should the pressure not hold or exhibit significant discrepancies, this would indicate a potential issue within the ELCM system, thus guiding the technician to realign their troubleshooting efforts accordingly. In this step of the troubleshooting procedure, the technician reconnects the hose to the canister one-way valve. This is a vital part of the process, as the function of the one-way valve is to ensure that fuel vapors are directed appropriately within the EVAP system while preventing backflow. By applying pressure through the vacuum pump to this component, the technician can assess its operational integrity. Any issues with the canister one-way valve can lead to misreads of pressure levels, potentially contributing to the triggering of DTC P24B9. It is essential to monitor the pressure levels after connecting the hose and applying pressure to determine if the readings are consistent with normal specifications. At this stage of troubleshooting, the technician applies pressure to the hose connected to the canister one-way valve. This application of pressure helps to validate whether the one-way valve is functioning correctly, allowing the technician to gauge the integrity of the EVAP system. Ideally, under normal conditions, the pressure should hold steady, reflecting the operational reliability of the entire system. If the pressure fails to maintain expectation, it may indicate a blockage or malfunction within the ELCM or the canister one-way valve itself. Therefore, observing the pressure readings is crucial for making an informed diagnosis about the component's condition, assisting in formulating the next steps for repair or replacement if necessary. After completing the necessary repairs or component replacements dictated by the diagnostic procedures, it is essential to conduct a final repair verification for DTC P24B9. This includes confirming that all systems function correctly and that the potential issues have been satisfactorily addressed. The technician should clear the diagnostic trouble codes stored in the vehicle's PCM to reset the monitoring systems. Following this, a test drive is often conducted to observe the vehicle under real-world conditions, ensuring that no further anomalies arise and that the check engine light does not reappear. This verification is critical for confirming that the repairs have effectively resolved the issues without introducing new problems in the emission system. To prevent recurrence of DTC P24B9, regular preventive maintenance of the EVAP system is recommended. Routine checks are essential to identify any potential blockages, ensuring that components like the canister one-way valve and drain tube are free from obstructions. Additionally, Monitoring the pressure sensor for any irregularities in performance can help catch issues early before they escalate into more significant problems. Regular maintenance becomes an important practice to ensure the longevity and effectiveness of the entire emissions control system. By taking these proactive measures, drivers can minimize the likelihood of triggering DTC P24B9 and maintain optimal vehicle emissions performance. In conclusion, DTC P24B9 indicates a performance issue with the evaporative leak check module pressure sensor, necessitating thorough diagnostics of the EVAP system. The systematic troubleshooting steps offer a structured approach for technicians to isolate and identify the root cause of the issue, whether it lies within the pressure sensor, the drain tube, or the canister one-way valve. Addressing DTC P24B9 is crucial not only for maintaining compliance with emissions regulations, but also for ensuring optimal vehicle performance. Regular preventive maintenance of the EVAP system can significantly reduce the chances of experiencing this DTC in the future. For Honda CR-V 2023 Plus owners, understanding this diagnostic trouble code is key to effective vehicle care. Please like and subscribe to the channel. See you next time.